Hello, we are Team Hack Orange and we're doing Challenge 5A. Our team consists of our team captain Louise Flatman, Rory Patterson, Frank Kilbride, Alessandra Zerlo and Becky Connolly. IEG data is a collection of independent assessments and validation for World Bank, International Finance Corporation and Multilateral Investment Guarantee Agency. For this challenge, we are working with data solely about World Bank. Our objective is to examine the way that a portfolio of projects is overseen by World Bank. The decision we are seeking to improve is in identifying which projects are unlikely to succeed and whether they should be cancelled, rescoped, supported, or monitored as a result. We need to train a machine learning model on our archive of projects and predict which projects are most likely to succeed and which to fail. The user story that we're focusing on is that of a portfolio manager for a large institution. They'd like to know which projects are unlikely to succeed so that they can rescope, support, or monitor these projects.
In terms of our data on the screen, you can see the source, overview, and the composition. The methodology and steps that we went through as part of this challenge and all the packages and programs used throughout the challenge are on the screen. We worked as a team to mind map and agree what we needed to produce for the product to navigate our effort and the challenge. Following this, we began to explore the data. We could see that we had a large data set, but many variables had a large proportion of missing data points. We also saw possible signs of duplication and needed to do some research to understand the meaning behind some of the variables, what the information in the columns was showing, and whether they were before or after the project completion. We created simple plots using pivot tables in Excel to explore the correlation between several variables and project outcome. This gave us an idea as to what variables may be significant to include in our model. Through the exploration of the data, we then knew what was needed to clean the data.
During the cleaning process, we had to resolve issues regarding American versus UK dates. We also created calculated columns for project duration and extracted the month from start and finish dates. Finally, we reduced outcome variables to binary from having multiple options, as our model would be designed to give a binary prediction of satisfactory or unsatisfactory. Other cleaning steps included correcting data types. All of this was done within Power BI.
Orange is an open source data visualization, machine learning, and data mining toolkit. The core principle of Orange is visual programming, which means each analytical step is contained within a widget. Widgets are placed on the canvas and connected into an analytical workflow, which is executed from left to right. First of all, we have carried out some transformation to the data. To produce a training test set, we selected a subset of the input data set, filtering out the data we wanted to predict once the model is ready. We preliminarily used the selected columns widget to manually compose our data domain. Here we can decide which attributes will be used and how. To build a classification model, the domain will be composed of a set of attributes and a target class attribute. The data sampler widget returns a selected percentage of the entire data, for example, 80% of all the data to train the model and 20% to test it. We then deployed a number of classification algorithms so we could understand which one would give us the highest accuracy. Random Forest builds a set of decision trees. Each tree is developed from a bootstrap sample from the training data. Once all of the models are deployed, we can measure the accuracy of each of them. The test and score widget shows a table with different classifier performance measures so that we can compare the accuracy of each model against the others, fine-tune the hyperparameters, and choose the most accurate model with the best hyperparameters. ROC. The widget shows ROC curves for the tested models. It serves the mean of comparison between classification models. The closer the curve follows the left-hand border and then the top border of the ROC space, the more accurate the classifier. Rank. The rank widget scores variables according to their correlation with the discrete or numeric target variable. In such a way, we can understand what features are more important for the model and retrospectively add or remove some of them. Finally, the predictions widget receives a data set and the most accurate predictor, in this case, random forests, and it therefore outputs the data and the predictions. With the confusion matrix, we can observe the proportion of instances between the predicted and the actual class. In this way, we can observe which specific instances are misclassified and explore why. We replicated this workflow with the original dataset, the downsampled and oversampled dataset.
But after our model had been built and we had our results, we had to then interpret this into a usable format for our intended client and end user. On the screen, you can see an example of how we are presenting the results. We took the result export from Orange and placed this into Excel. We took the project code, predicted outcome, and the satisfaction rating as a means of assigning a numerical number to each result. We then grouped satisfaction rating values and assigned recommended outcomes based on this. We used conditional formatting to make it as easy as possible for the user to interpret. From the screen, you can then see that for each project, you can clearly see the recommended outcome and which projects need the most immediate attention.
The first step in preparing our data for training the model was to remove all outcomes which were null or not available. We then initially fitted our model, and we noticed that it was biased in favor of satisfactory, as our trained sample was overwhelmingly satisfactory. We attempted to remedy this by using a random sample generator function written in Python to reduce the satisfactory count to match that of the unsatisfactory group. This was not the correct approach, as reducing our sample size reduced the model accuracy. We subsequently tried to oversample the train dataset by duplicating unsatisfactory lines in order to reduce the disparity between the satisfactory and unsatisfactory outcomes without reducing the sample size. This produced a better result. Our final model had an accuracy of approximately 82%, but of course there is still room for improvement. Firstly, we would attempt to identify further data sets for which we could run our model. Next, we would like to do further analysis of feature strengths to see if there is any further scope for optimization. Finally, we would like to explore examples of where our models misclassified the outcome and look for commonalities